All right, yesterday we were talking about sine and cosine waves. Talking about sine and cosine waves. Now, today we're going to look into tangent graphs. Graphs of tangent. And you've already had the opportunity to graph just y is equal to tangent of x. Is tangent related to sine and cosine as far as the graphs are concerned? No. What differences automatically right off the bat do you know that we have different with tangent than we did with sine and cosine? They're shaped different, absolutely. What do we know about sine and cosine with its shape? Okay, they're horizontal, and isn't it true that sine goes up to that a value, and sine and cosine, they go up to that a value, down to negative a, back up to a, down to negative a, back and forth, back and forth, back and forth. Is that going to happen with tangent? No, because what happens with tangent? Where does tangent approach? The asymptotes. And it gets infinitely larger and infinitely smaller when it approaches those asymptotes. Do I have a maximum or a minimum value for tangent? No. What else do I have on my graph for tangent that doesn't exist on my sine and cosine graphs? The asymptotes. I have asymptotes when I have that tangent graph. Okay, so now as we look at this, we look at y is equal to a tangent of bx. Okay? How do I find the period for sine and cosine? 2 pi over absolute value of b. Tangent, it's pi over the absolute value of b. Tangent is pi over the absolute value of b. And then we have those asymptotes that we did not have on sine and cosine. To find those vertical asymptotes, they're at odd multiples of pi over 2 absolute value of b. So to find my vertical asymptote, I'm going to be at x is equal to pi over 2 absolute value of b. I go to the right, pi over 2 absolute value of b. And then there's also one when I go to the left, pi over 2 absolute value of b. So I have those two asymptotes, or actually infinitely many asymptotes that I did not have with tangent. We're going to look at this. We're going to graph one cycle just like we did with sine and cosine, knowing that that pattern continues to repeat itself indefinitely. Okay, so when we're graphing our 5 key values, of tangent, y is equal to tangent of x, y is equal to a tangent of bx. Y is equal to a tangent of bx. Our 5 key values are not 5 points like they were with sine and cosine, okay? First of all, 2 of the most important things on that graph are going to be our asymptotes, okay? So we're going to have our asymptotes on that graph. At x is equal to pi over 2 absolute value b, and the second one is x is equal to negative pi over 2 absolute value b. Remember, thinking Vux, so x equals. On my graph, those asymptotes are going to be those dashed lines. My graph approaches, but never touches. Okay, the next thing I'm going to put on my graph, is the y-intercept. Now, where is my y-intercept? Where does this graph cross the y-axis? At 0, 0. Absolutely. At 0, 0. So my y-intercept is going to be 0, 0 for y is equal to a tangent of bx. Okay. And then last but not least, we have 2 other points. Two other points that I'm going to put onto this graph. Now, they're not your minimum, they're not your maximum, they're not any x-intercepts, but they're very interesting points for tangent. And these points occur halfway between 0, 0 and my asymptotes. Okay? Now, here I am at my asymptote. I was at x is equal to pi over 2 absolute value b, and here I'm at x is equal to negative pi over 2 absolute value b. Okay? So what I'm going to do is I'm going to go halfway in between 0, 0 and my asymptote. I'm going to go halfway in between 0, 0 and my asymptote. Because when I go halfway in between 0, 0 and my asymptote, I'm actually up a value. If I find that point, I'm up a value of A. And over here, if I go halfway between 0, 0 and my asymptote, when I go down, I'm actually at a value of negative A. Okay, so this point, I am halfway to the pi over 2 absolute value of B. So if I want to find this point, I am halfway to pi over 2 absolute value B. And then what's my y value at that spot? The A. For tangent, that A, there is no amplitude. It doesn't get used for anything else. Now here at this point, I'm going to be halfway between 0, 0 and this asymptote. So in this case, I am halfway to negative pi over 2 absolute value of B. And my y value is negative A. So for tangent, my 5 key values are the 2 asymptotes, the y-intercept, and the 2 extra points that are halfway in between my y-intercept and those 2 asymptotes. Are we okay with that? All right, so let's see this in action. Okay, let's see this in action. All right, we have y is equal to 1/2 tangent 1/3 of x. Y is equal to 1/2 tangent 1/3 of x. Okay, so the first thing you need to do is write y is equal to a tangent of bx. Y is equal to a tangent of bx. So what is my a value? 1/2. And what is my b value? 1/3. Okay, now with tangent. With tangent, what does a do for me? Nothing special like it did with sine and cosine. Nothing special like it did with sine and cosine and help me to find my amplitude. What do I do with my b value for tangent? It helps me find what? The period. Okay, it helps me find the period of my graph. Okay, now for tangent, how do I find the period? For tangent, how do I find the period of my graph? All right, pi over the absolute value of b. Okay, so we have pi over the absolute value of my b value of 1/3. So pi divided by 1/3. Okay, how do I divide by a fraction? Perfect. So pi times 3 over 1 is 3 pi. Okay, now here's the deal with tangent. My period is 3 pi. 1 full cycle is 3 pi. Now think about what that means. 1 full cycle, that means from one asymptote to the next asymptote with one little mini snake curve in there, it's a distance of 3 pi. Then, from this asymptote to the next asymptote, it's going to be a distance of 3 pi. Now for tangent, that's good information, and that's something we need to know, but that's nothing that translates onto my graph. Does that make sense to you? The period for tangent is the distance from one asymptote to the next asymptote because that is 1 full cycle of my graph. Now, with tangent, what I'm really most concerned about is knowing what? Where are the asymptotes? Absolutely. We need to know where those vertical asymptotes are. Okay, now, one of the vertical asymptotes is going to be at x is equal to pi over 2 absolute value b, and the other vertical asymptote for my first cycle is going to be at negative pi over 2 absolute value of b. So here we have pi over 2 absolute value of a third. So that's going to be pi over 2/3. And when I multiply by the reciprocal, we get 3 pi over 2. So my first asymptote is that x is equal to 3 pi over 2. We're thinking about Vux. Is everybody with me on that algebra? Okay, my second asymptote is going to be at negative pi over 2 times the absolute value of b, which is 1/3. So negative pi over 2 times 1/3 is going to be 2/3. Negative pi multiplied by the reciprocal, negative 3 pi over 2. So x is equal to negative 3 pi over 2. All right. So my vertical asymptote, I go to the right 3 pi over 2, I'm going to get to a vertical asymptote. I go to the left 3 pi over 2, and I'm going to get to a vertical asymptote. Now notice, with tangent, with sine and cosine, I put my y-axis over here because I knew my cycle was going to go to the right. Does that make sense? But with tangent, it doesn't. Tangent, my y-axis needs to be right there in the middle because my graph is equally distributed on each side of the y-axis. Does that make sense to you? Okay, so my first vertical asymptote is at 3 pi over 2. So I'm going to go to the right 3 pi over 2. And I'm going to put a vertical asymptote in there. I'm going to go to the left 3 pi over 2, and I'm going to put my other vertical asymptote in there at negative 3 pi over 2. Okay, now, just a comment. What's the next point that's going to go on here? 0, 0. My y-intercept is at 0, 0. Okay, then I need 2 other points. I need 2 other points, and the other points that I'm going to find are halfway in between 0, 0 and each of my asymptotes. So, halfway between 0 and 3 pi over 2. Well, what's half of 3 pi over 2? 3 pi over 4. So that means I'm to the right 3 pi over 4. Then halfway between 0, 0 and negative 3 pi over 2. What's half of the way to negative 3 pi over 2? Negative 3 pi over 4. Now, what is interesting about 3 pi over 4 and negative 3 pi over 4? Where am I at those 2 points? At 3 pi over 4, I'm at the A. I'm at the A. Now, what was my A value? A half. So that means I'm going to go up, let's see here. Let's see, go up a half, go up 1, go down a half, go down 1. Okay? So at 3 pi over 4, halfway between 0, 0 and my asymptote, I know I'm up at that A value of a half. Halfway between 0, 0 and negative 3 pi over 2, I'm down an A value, so I'm down 1/2. And then I should be able to draw in that mini snake curve. So that means that it goes up towards that asymptote infinitely, and it goes down towards the asymptote in this direction infinitely. Okay, so as we look at this, what's the amplitude of this graph? What's the amplitude of this graph? There is none. Remember, amplitude's half the height. It's the maximum minus the minimum divided by 2. I don't have a max or a min. There is no amplitude for tangent. There is no amplitude for tangent. Okay, what about the period? 3 pi. The distance from one asymptote to the next. So here from negative 3/2 is 1/2. So here I have 1/2 pi. Here I have another 1/2 pi. So the distance of one full cycle is 3 pi. All right, my asymptotes. X is equal to negative 3 pi over 2. and x is equal to positive 3 pi over 2. Now my 5 key points. My 5 key points for tangent are not all going to be points. Yes, I'm going to repeat. I'm going to put my 2 asymptotes down because they are important guides for my graph. And then the other 3 will be the key points. So I'm at negative 3 pi over 4, negative a half. I'm at 0, 0, and then I'm at positive 3 pi over 4, positive a half. All right, what's my domain? What is my domain? All real numbers except I can't have values where I have the x asymptotes. So x cannot be equal to negative 3 pi over 2 or positive 3 pi over 2. And yes, we're just going to limit it to one cycle. And I'll talk about that in a minute. What's my range for tangent? All real numbers. Okay, now I got a comment. With sine and cosine, we graphed just one cycle and we knew it went forever in both directions. Please remember with tangent, don't draw this, don't write this down, but please remember with tangent, does it continue forever? Yes. So I could over here, do that on this side, I could over here say, well, you know what? This continues off to the left. This continues off to the left. And if this distance is 3 pi over 2, that means if I go to the left another 3 pi, if this distance is 3 pi from one asymptote to the next, that means if I go to the left another 3 pi, well, if this is negative 3 pi over 2, this is 3 pi over 2. If I take 3 pi away, let's see, negative 1.5 and negative 3, this would be negative 4 pi over 2, so negative 9 pi over 2. And then if I add 0, 0, I go to the left 3 pi, which would make this 3 pi, negative 3 pi. I could put another snake curve in here, mini snake curve again. Does that make sense? This would go again and again and again and again. But we're just showing one cycle of tangent. But don't lose sight of the fact that this continually repeats itself infinitely in both directions. Questions? Any questions? All right.